Dimensional analysis, also known as the factor label method, a science production. So why do we use dimensional analysis? It's used to convert from one unit to another. It organizes information and helps you keep track of units. And it can be used as a shortcut by combining different conversion factors. Now, what the heck is a conversion factor? It's a ratio, or equivalency means equal to, from one unit of measurement or just a unit to another. For example, you can have 12 inches for every 1 foot, or 12 inches equals 1 foot, or 4 quarts in a gallon, or 1 human, 2 eyes. It's made possible by the following mathematical rule. If the same value appears in the numerator of a fraction and in the denominator of a fraction, they cancel. If it's in the numerator, it's usually mean multiply by, and if it's in the denominator, the bottom, it means divide by. So it's kind of like opening and closing a door. If I open the door and close the door, it's almost like I never even touched the door because it's back to its original position. Take a look at this fraction. You have a third times 3 halves times 2 fifths. Why would I multiply by 3 when I'm just going to divide by 3 later? I'm going to undo what I just did. So if it appears in the numerator and the denominator as a pair, it cancels. So the 3 cancel. Do you see anything else that might cancel? The 2 cancels. So what was previously kind of looked like a pretty long problem turns out to be 1 divided by 5, 1/5. Now, with an emphasis on working smarter, not harder, I still want to talk to you about how you're supposed to solve numbers that you see in the numerator and the denominator. What if they don't cancel? You still have to do the math. So let's see what that looks like. Here we have a problem, 1 times 3 times 4 over top of 12 times 2. This could be combined after you crossed out everything, and these are the ones that still won't cancel out. Nothing that appears in the numerator has a partner in the denominator that would allow it to cancel. So here's what you don't want to do, is you don't want to stop and simplify the numerator. 1 times 3 times 4 equals 12, write it down. Hit clear on your calculator. 12 times 2 equals 24, write it down. And then do 12 divided by 24, which is a half. That's the long way of doing things. If you have a calculator, let's let the calculator do all the work. So instead of simplifying the numerator and denominator, do it all at the same time. If it appears in the numerator, it's the same as multiplying across the top and dividing across the bottom. So instead of 1 times 3 times 4 and then write it down, and 12 times 2 and then write that down, do multiply across the top and divide across the bottom. 1 times 3 times 4 divided by 12 divided by 2. Okay, even though it says 12 times 2, since it's in the denominator, it means you're dividing by each of those individually. And you still get the same answer, 1/2, except you don't have to stop and write anything down. You let the calculator do all the work for you. Now, the same way that it works with numbers, it also works with units. So let's say you have a word problem. So you're hosting a party and everyone has agreed that pizza is the best choice for what they want to have for a snack. Each friend says that they'll eat 3 slices of pizza, and each pizza comes in 8 slices. So if you invite 15 people to your party, how many pizzas will you need to purchase? Okay, it's a real life example. What would hence do? So I'm going to teach you what I would do when I try to solve these problems. The first step is I try and identify the starting point and the end point. In other words, what do I have to begin with? And units, and what are they asking me to convert it into? So if we look in the problem, I see that I have 15 people or friends, and I need to know how many pizzas. In other words, 15 friends equals how many pizzas. I don't know off the top of my head. That's why we're using dimensional analysis. Step number 2 is you want to be able to identify all the conversion factors needed to be successful. So we can look in the problem for contextual clues as to other conversion factors. Now, conversion factors don't have to always be measurement equalities, like 5,280 feet equals 1 mile. We can look in this problem, and they gave us a ratio or fraction or equality. So each friend says that they'll eat 3 slices of pizza. That's a conversion factor. And each pizza has 8 slices in it. That's another conversion factor. So I know that 1 friend equals 3 slices and 1 pizza equals 8 slices. So what does this look like when I use dimensional analysis? I have my starting point, 15 friends. Okay? Now, I want to cancel out of friends. I don't want to know how many friends I have. I already have that number. I want to know how many pizzas I need. So if I don't want the unit friends anymore, I want it to cancel. I need to be able to cancel the unit. So if friends, right now, 15 friends, that's a whole number. So it's really 15 friends over 1 if I wrote it as a fraction. 15 friends is a numerator. So if I want to cancel out of friends, I need friends to be in a denominator. So the next conversion factor, I want friends and the denominator, but I need something that it's equal to on the top in a different unit. So what it looks like is I put 1 friend on bottom and 3 slices, since each friend eats 3 slices. And since friend is in the numerator and the denominator, they cancel. So now my units are not in friends anymore. I now have it in slices. If I stopped right now and did 15 times 3 divided by 1, okay, 45 slices. But you don't buy pizza in slices, you buy it by the whole round, the pie. So I need one more conversion factor. I have my answer right now in slices. I don't want slices. So how am I going to get rid of slices? Well, slices is in the numerator, so I need the next conversion factor to have slices in the denominator. So I want 8 slices for every 1 pizza. Now slices cancel because it appears in the numerator and the denominator. Now all I have to do is multiply across the top and divide across the bottom. 15 times 3 divided by 8. I ignored the ones because multiplying and dividing by 1 doesn't change the number. So 15 times 3, 45 divided by 8 gives me 5.625 pizzas. But you can't order 0.625 of a pizza. So let's just round that up to 6 pizzas. And that's how you apply the dimensional analysis technique to convert from one unit to another. This is really important for those in the United States because almost everywhere else in the entire world, everyone in science specifically uses the metric system. And we as stubborn America, we still use English units, okay? Instead of meters, we use feet and yards. Instead of liters and milliliters, we use cups and gallons. So it's important to know how to use dimensional analysis to convert for science. Thanks for watching.